All right, good afternoon and welcome to Maths Atoka online class. In today's video, we'll be solving questions on set and Venn diagram. Right, set and Venn diagram. Okay, we have a full video on set and Venn diagram. You can watch that. In this particular video, we are just focusing on solving questions. All right. So if you have not watched our video on that particular one, I'll drop the link on the description so that you will understand it perfectly. Okay. So the first question here, question number one said, let x and y be two sets such that the number of elements in x are 28, the number of elements in y are 20, and the number of elements in x intersection y is equal to 36. Then I say find the number of elements in x union y. Okay, so having this now, what do we do? This is a very simple question. Solution: you need to know a formula that say that the number of elements in x union y is equal to the number of elements in x plus the number of elements in y, then minus the number of elements in their intersection, so x intersection y. So if you do that, you're going to have 28 plus 20, then minus 36. So if you do that, you're going to have 28 plus 20 minus 36. You're going to have 12. Okay, so that is that. We move to the second question. The second question said number 2. It said if the number of elements in x minus y, okay, is equal to 18, comma, the number of elements in x union y is equal to 70, and the number of elements in x intersection y is equal to 25. Then I say then find the number of elements in y alone. Solution: you should know a formula that say that the number of elements in x is equal to the number of elements in their intersection first, then minus the number of elements of y will come. I'm looking for x, but y will come first. Y minus x. Okay, so but if you're looking for the number of elements in y, is going to be the number of elements in their intersection, okay, minus the number of elements. X comes first. Okay, so you should know that if it is y here, that x will come first. So this is equal to the number of elements in this is what they are asking us. This one is 25 minus sorry, their union, not their intersection. Sorry, their union, not their intersection. So this one is 70 minus 18. So 70 minus 18 will give you 52. 70 minus 18, 70 minus 18, I'm having 52. Okay, now there's another alternative method of solving this alternatively, but I know you like this one I used. Alternatively, now what do? You should know that the number of elements in x union y, okay, is equal to the number of elements in their intersection, x intersection y, plus the number of elements in x minus y, then plus the number of elements in y minus x. You need to know this. Okay, so let me explain this with a Venn diagram. This one I wrote now, look at it in a Venn diagram now. If I have this and this is my x, this is my y. If you want to unite x union y, means everything here. So which means it means only this one plus their union plus their intersection, what they have in common, plus only this one. That is what I just wrote now. All right, so if you now put it here, you're going to have that this one is 70 is equal to number of x intersection y gave us 25, sorry, 25 plus this one gave us 18, this one gave us 18, then plus n y intersect y minus what, minus x. So if I collect items, I'm going to have that 70 minus 25 minus 18 is equal to ny minus x. So if you do that, you're going to have 70 minus 18 minus 25. I'm going to have 27. So the number of y minus x is equal to what? 27. So you should know that the number of y alone is now equal to the number of the intersection first, that is x intersection y, then plus the number of y will come first now, y minus x. All right. So now look at that. Now, to get everything about y, look at everything about y is their intersection plus only y, because x minus y minus x means only y. So that is that. So if you add the both of them, you are going to have, if you add the both of them, you are now going to have that the number of y alone is now equal to 27 plus 25, or 25 plus 25, 25 plus 27, which is going to give you the same 52. So it depends on the one you can remember. So anyone you remember is very, very okay. So we'll move to the next question, which is question number 30. Sorry, question number 3. Question number 3. Question number 3 said there are 35 students. There are 35 students in maths, in mathematics, mathematics class, and 57 students in physics class. Then they now say find the number of students who are either in math class or in physics class. Okay, they now give a condition. The first condition they gave, that one, when two classes meet at different hour and 15 students are enrolled in both classes, in both activities. Okay, then I said when two classes meet at the same hour. Okay, now this is a very simple something to solve. Now what do we do? Okay, let me solve it here. Solution. Now we have that that the number of let me say maths. Okay, the number of maths they gave us was 35. The number of physics they gave us was 57. So they now say that we should find the number of maths union physics. Okay, which is what? You should know the formula, which is the number of maths plus the number of physics, then minus the number of their intersection, math intersection physics. So you should know that mass intersection physics say that when the both class held at different hour, 15 students attend the two of them. So I'm going to have 15 students. Okay, is it minus or plus? I think it should be plus. It should be plus the union, not subtraction. Okay, so I'm going to have that m union p is going to be what? Is going to be 35 plus 57 plus what do we have there? The intersection is 15 plus 15. So I'm going to have is it plus or minus? I think it's minus. Sorry, not plus. It's minus. Is minus because there is no repetition. This is found inside the two of them, so it's minus. Yes, not plus. Okay, so I have 35 plus 57, then minus 15. So I have 77. So for the I now, They say that in II that the class held at the same time. So if they are at the same time, then there is no intersection. So at this point, the number of M intersection P here is 0. Okay, is an empty set, is 0. So what do we have now? So we are going to have that the same formula, that the number of M union P is equal to the number of M plus the number of P, then minus the number of M intersection P. Right? So what do we have now? We are going to have that this is equal to what? 35 plus 57 minus 0. So I'm going to have so 35 plus 57. So I'm going to have 92. Okay? So that is that for that. So we'll move to the next one. Question number 4. So for question number 4, question number 4 said let u be equal to the set of all natural numbers, less than all natural numbers that are less than all natural numbers less than or equal to 30, less than or equal to 30. Okay, then they now say that x is equal to the set of factors of 24. Okay, then I say that y is equal to the set of even numbers greater than 2, but less than or equal to 12. All right, then they now say that z is equal to factors of 28. Okay, so now let us get all these things before we start answering the questions. Solution, let me get all these things, then I will now be writing the question here and be solving it. First of all, we need our universal set. Our universal set is equal to the set of what? From 1 to 30, all natural numbers less than 30. So from 1 to 29, all natural less than or equal to 30. So you will say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me say dot 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 30. I don't have the strength. You can list your own. Okay, so they say we should list them. So now the next one is our x. Our x are the set of factors of 28 24. How do you get the factors of 24? Just by LCM. 24, 2 divide 12, 2 divide 6, 2 divide 3, 3 divide 1, 1 divide 1. So the factors of 12 are everything you can get from here. Watch me the way I'm getting it. 1 is here, 1. 2 is here, 2. 3 is here, 3. Is 4 here? Yes, 2 times 2 is 4. 4 is here. Is 5 here? No, 5 is not here, but it's 6 here. 2 times 3 is 6. 6 is here. What of 7? 7 cannot be here. 8, yes. 1, 2, 3 will give us 8. 8 is here. Is 9 here? No. 10 here? No. 11 here? No. 12 is here. 12. And then finally 24. Okay, so these are the factors of 24. So the next one, z, but they say that, okay, sorry, y. So for y they say that even numbers greater than 2 but less than 12. So you have 2, 4, 6, 8, 10. 2, 4, 4, 6, 8, 10, and 12, less than or equal to 12. So it should be greater than 2 but less than or equal to 12. So z finally, z is now the set of what am I saying? Z is equal to the set of factors of 28. Let's do the same thing for 28. So if we do the same thing for 28, 28, 2 divide 14, 2 divide 7, 7 divide 1. So 1 divide 1. So what are the things we can get here? 1 is here, 2 can be here, 3 is not here, but 4 can be here, 5 cannot be here, 6 cannot be here, 7 is here, 8 is not here, 9, 10, 11, 12 cannot be here, 13, 14 can be here, because 2 and 7 is 14. Then finally 28. So these are the factors of 28. So now the next thing we need to get is our x prime from the question, but I'll show you the question, but let's get our x prime. X prime means element you can find in the universal set that you cannot find in that x, that is x prime. So let's go. We have 1, 2, 3, 4. 5 is not here, so 5. 6, 7 is not here. 8 is here. 9, 10, 11, 12 is here. 12, yes, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 is here. So you say 25, 26, 27, 28, 29, 30. So this is my x prime. So my y prime are the elements you can see in the universal set that you cannot see in y. So let's go. 1, 2, 3, 4 is already here. So 5, 6 is already here. So I have 7, 8 is already here. 9, 10 is already here. 11, 12, 12 is already here. So 13, 14, 15, up to that 30. All right. So what about z? Z prime. Z prime is element that you can see in the universal set that is not in z. So 1 is already here. 2 is already here. So we start from 3. 4 is here. 5, 6, 7 is here. So 8, 9, 10, 11, 12, 13, 14 is already here. So I'll say 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 is already here. So I have 29 and 30. So now let us start answering the questions. So the question now, the first question, I. So sorry, the first question, I said we should find x intersection y intersection z. Now it means what the three of them have in common. Problem. So let us check out. um ah let's go. So let's check out what the three of them have in common. Sorry, from here, what the three of them have in common. So one is not here. One is, so let me start from 4. 4 is everywhere, so I say 4. Okay. 6 is not everywhere. 8 is not everywhere. 10 10 is not everywhere. I'm using the smallest one. Okay. 10 is not everywhere. 12 is not everywhere. So the only thing they have in common is 4. 4 is the only common term they have. Okay. So the next one is so the next one is what? I. So I now said I said x union y, then intersection z prime. Okay. First of all, we need x union y. Now for x union y is to bring, first of all, x union y is to bring x and y together. So x and y together is x union y. Then x union y, okay, let me just do it gradually. First of all, x union y, let me do it like this. X union y will give you, bring them together, which is what? 1, 2, 3, 4. 5 is not in. 6, 7 is not there. 8, 9 is not there. 10, 12, and then 24. Okay. So this is x union. Now intersection z prime. Now intersection z prime is this one and your z prime, what they have in common. So let's check what they have in common. So finally, what they have in common is 1 is here, 1 is not here. So 2 is here, 2 is not there. 3, okay, we start from 3. 3 is here, 3 is here. 3, 6, 4 is here, 4 is not here. 6 is here, 6 is here. 6, 8 is here, 8 is here. 8, 10 is here, 10 is here. 10, 12 is here, 12 is here. 12, 24 is here, 24 is here. 24. So this is the answer to this question. So the answer to this question is 3, 6, 8, 10, 12, and 24. Right. So we'll move to the next question. The next question is I. Permit me to clean this one already. So I said x prime intersection y prime intersection z. I don't know if that z has prime because my own is not clear. But if it has prime, you know what to do now. I have listed out the things for you. So prime intersection means what they have in common. So now, who is the smallest? The smallest person here is Z. So I'm using Z now to check what they have in common. So I'm checking Z with my X prime and Y prime. So 1 is here, 1 is here, 1 is not here. So I'm not taking 1. 2 is here, 2 is here, 2 is not here. I'm not taking 2. 4 is here, 4 is not in the two of them. 7, oh, 7 is everywhere. So 7 is the first person. 14, 14 is here, 14 is here, 14 is the next person. 28, 28 is here, and 28 is here, because this is dot dot dot, so 28. So this is the answer to this. So IV. But if there is prime here, then you are comparing these three things, what they have in common. Okay, so please check out your own. My own is not that clear. So Ivy said X intersection Y prime intersection Z prime. Okay, so now we check the smallest one. The smallest one there is X. Where do you have the smallest element is X? So we'll start from here. 1 is not even, okay, 1 is here, but 1 is not here. 1 is not among. 2 is here, 2 is not here, 2 is not among. 3 so 3 is what they have in common. 4 is not here, it's not among. 6 is not here, it's not among. 8 is not here, it's not among. 12 is not here, it's not among. 24 is here, and 24 is equally here. So 3 and 24 is the answer here. So V said X prime intersection Y prime intersection Z prime. Okay, so that is what these three people have in common. So who is the smallest I can use? Who has the smallest thing that I use? Okay, let me start with this one that has 5. This one that started with 5. So I have 5, 5, and 5. So 5. 7. There is no 7 here. Okay. There is no 7 here. 7 is not among. 9 is among. 10. There is no 10 here. 11. 13. 14. There is no 14 here. Okay. 15. 16 is here because of this dot dot dot. 16 is here. 17 is here. 18 is here. 19 is here. So 20 is there. 21 is there. 22 is there. 23 is there. 24 is not here, so it's not among. 25 is here. 26 is here. 26 27 is here. 27 is here. 27 28, but there's no 28 here, so it's out. So 29, then 30. Okay, so that is that. So VI. So for VI said X prime intersection Y intersection Z. Okay, so who is the smallest person there? The smallest person there is our Y. So I'm comparing Y, Z, and our X prime. So 4, there is no 4, so it's not among. So 6, there is no 6 here, it's not among. Okay. 8, there is no 8 here, it's not among. 10, there is no 10 here, it's not among. 12, there is no 12 here, so this is an empty set. So it's empty. So they don't have anything in common. So we move to the next question. Question number VII. Question number VII. So question number VII said X prime intersection Y intersection Z prime. Okay. So the smallest one there is our Y. So 4 is here. 4 is here. 4 is not here. 4 is not here. So 4 is not among. 6 is here. 6 is not here. Sorry. 4 is here. 4 is not here. And 4 is not here. So it's not among. 6 is here. 6 is not here. It's not among. 8 is here. 8 is not here. It's not among. 10 is here. 10 is here. And 10 is here. So 10. So the next person, 12 is here. There is no 12 here. So the only element here is 10. So VIII. You have to be very, very careful. If not, you will make mistake. So VIII said our X union Y union Z. So it's simply to bring them together. So let's go. I have 1, 2, 3, 4. There's no 5 anywhere. 6. There's no 7. Okay, 7, 8. There's no 9 anywhere. There's 10. There's no 11. There's 12. There's no 13. There's 14. There's no 15. There's no 16, 17, 18, 19 until you get to 24 and then 28. So that is that for that. So we'll go to question number 5. Let me check if it's still moving. Yes, question number 5. So for question number 5, question number 5 said in a survey of 20 students in a class, comma, 10 liked maths, comma, 15 liked chemistry, comma, 7 liked both subjects. Okay, then I say I create a Venn diagram. Create a Venn diagram to show this information. Okay, I said how many students like maths or chemistry. Okay, I how many liked chemistry but not maths. IV how many students didn't like either. Okay, now solution. What do we do? Let us draw the Venn diagram. To draw the Venn diagram, I have this. So I have the first one math and the second one chemistry. So this is my math and this is my chemistry. Now, in drawing a Venn diagram, you must start from the intersection. So they say that 7 like both. So I'm having 7 here. Okay. Now they now say you now go to 1 1. 10 like maths. I did not see only, so I must subtract. I will say 10 minus 7, which is what? 3. So 3 will be here. So the next one is what? 15 like chemistry. I did not see only, so I will say 15 minus 7. But if I see only, I'll just write it without subtracting. So I have 8. Okay. So now we did not see anybody that don't like at all. We call it X. So how do you find your X? You will now add everything in the universal set, equate it to 20 students. So I have 3 plus 7 plus 8 plus that X is equal to what? 20. So this is 18. 18 plus X is equal to 20. So X is equal to what? 20 minus 18, which is equal to 2. So here is your what? Is your 2. So question number 1 said we should create a Venn diagram for that. So you create your own Venn diagram. I want to make it small. Here, say math and chemistry. Then now write it normally. Here is 7, here is 8, here is 2, and here is 3. That's for the first question. So I said how many students like math or what? Or what is it called? or chemistry. So how many that like math or chemistry? Simply math or chemistry is number of math union chemistry. Okay, so which is what? Everything inside this place, which is what? 3 plus 7 plus 8. So what do you have? 3 plus 7 plus 8. Let me say 3 plus 7 plus 8. So I'm going to have 18. Okay, but let us see with this formula, math union chemistry, to give you number of math alone plus number of chemistry, then minus number of math intersection chemistry. Let's see if it will work. Number of maths is from this one. I did not see only, so it's this one that I'm using. That is 10 plus number of chemistry is 15, then minus their union is 7. So let's see what we are going to have. 10 plus 15 minus 7. So I'm having the same 18. See, the same 18. So any method you like will still give you the same answer. So the next question said, how many like chemistry but not maths? Chemistry but not maths means only chemistry, which is what? You write only chemistry, which is what? 15 minus 7, which is what? 8. We have already gotten it as 8. So the next one is IV. IV said, how many students did not like at all? We've gotten it as 2. So the number of students, write the statement. The number of students that does not like at all is 2. Use the statement to get your answer. So write the number, how many students, the number of students that didn't like either is equal to 2. All right. So that is that. We move to the next question. Question number 6. So question number 6. So question number 6 said, in a class survey, 105 students were asked whether they would write Igbo language, Yoruba or Hausa. These are the three languages, the three main languages we have in Nigeria. All right, Hausa languages in WAEC. WAEC is an examination, West African Examination Council. Examination we write in Africa. All right. Then I say here are their responses. Okay. 5 are writing all 3 subjects. Okay. 9 are writing both Hausa and Igbo. Please permit me to use abbreviation. So the next one, 11 are writing both Hausa and Yoruba. The next one, 24 are writing both Yoruba and Igbo. Okay. Then 52 are writing Igbo. Then 63 are writing Yoruba. Then finally 25 are writing Hausa. Okay. So the question now say create a Venn diagram. We'll start answering the question. Let me just create the Venn diagram first, so that from the Venn diagram we can be answering the question. Okay. So now let me have the Venn diagram. This is my own Venn diagram. Okay. So I told you that anytime you are drawing a Venn diagram, you must start from the intersection of how many they are. Then you now move out. I have my Igbo, my Yoruba, and my Hausa. Naming them, the way you name them does not matter. So let's start from the 3 of them. They say 5 are writing the 3 of them. So I have 5 here. Okay. Now they now say that 9 are writing both Hausa and Igbo. So we have gone to 3. So now let's go to 2 2. So 2 2 now said 9 are writing both Hausa and Igbo. But I did not see only. So I will tell them only Hausa and the Igbo will now be what? That's 9 I'm seeing minus that 5 to give you 4. So Hausa and Igbo. Hausa and Igbo. Look at the intersection. So I have 4 here. Okay. So they now say 11 for Hausa and Yoruba. They did not see only. So you tell them only Hausa and Yoruba will now be what? That 11 minus that same 5 to have what? 6. So Hausa and Yoruba, this is the intersection. You have 6 here. So the next one is what? 24 Hausa and Igbo. So you now say only because I did not see. But if you see only, just write it. But if you not see only, you must subtract that intersection of the 3 of them. So I have only Yoruba and the Igbo is equal to what? That's 24 minus 5, which will give you 24 minus 5 to have 19. So I have 19. So here will be what? 19. So now let's go to 1 1. So now 52 write Igbo, but I did not see only. So to get only Igbo will now be 52 minus everything that entered inside of Igbo. So let's check everything that entered inside of the circle of Igbo. Now 4 entered, 5 entered, and then 19 entered. And we'll subtract everything to have 52 minus 19 minus 4 minus 4 minus 5. So I'm having 24. So only Igbo will now be 24. So here will be what? 24. So let's do for the next one, Yoruba 63. But I did not see only. But if I saw only, I'll just write it here. But for the fact that I did not see only, I will calculate for the only. Only Yoruba will now be what? 63 minus everything that entered inside of that Yoruba. Let's go. 19 entered, 5 entered, and 6 entered. So I'm going to have 63 minus 19 minus 5 minus 6. So I'm having 33. So I'm having 33 here. So here will be 33. Then finally, only Hausa. Only Hausa will now be what? 25 minus. Please be checking that question if there is anything like only there. Okay, there is nothing like only, so I must subtract everything that entered inside of Hausa. So 25 minus 4 minus 6 minus 5. So I'm going to have 10. I think it's 10. 25 minus 5 minus 6 minus 4 is 10. So I'm having 10 here. So 10 is here. Now, they did not tell us about people that did not want to write any of the 3 languages. So let it be what? Let it be X. So how do we calculate our X? Add everything in this box and equate it to your 105. So you say 24 plus 19 plus, sorry, don't follow it like that so that you don't make mistake. Write 111, then be entering inside. So 24 plus 33 plus 10, then plus 19 plus 4 plus 6, then plus 5 plus the X is equal to your 105. So add everything here. 24 plus 33 plus 10 plus 19 plus 4 plus 6 plus 5. Okay. 24 plus 33 plus 10 plus 19 plus 10 plus 5. So I'm having 101. So 101 plus X is equal to 105. Therefore, my X will now be 105 minus 101. So my X is equal to 4. So 4 people did not write any of these 3 languages. Okay? They don't want to write any of the 3 languages. So this is my Venn diagram, done and dusted. So from this Venn diagram, you can now answer anything you are asked to answer. In fact, we have already answered almost everything, sef. But let me just be answering it for the answering sake. Then you now start from number 1. After writing all this, start from number 1. They say create a Venn diagram. This is my Venn diagram. So number 2 said how many are writing Yoruba but not Igbo? How many okay, they say, let me see, how many are writing Yoruba but not Igbo? Okay, now let's see the people that will write Yoruba but not Igbo. Okay, so first of all, the people that will write Yoruba, you come to Yoruba. we know normally that 33 are writing only Yoruba, plus now 6 are writing Yoruba and Hausa. So this is Igbo, not 1. Now 6 are writing Yoruba and Hausa, so it will be plus 6. I cannot add 5, I cannot add 19. They wrote Igbo. So my answer will now be 33 plus 6. 33 plus 6, which is 39. Okay? I. So we go to the next one. The next question said, how many are writing sorry, I. This one is I. How many are writing Hausa but not Igbo again? Okay, so we'll go to Hausa. 10 is already writing only Hausa. Then 6 is writing Hausa and Yoruba, so plus 6. So which is what? 16. We cannot add 5 and we cannot add 3 because they wrote Igbo. So IV. IV said, how many are writing Igbo or Yoruba? Okay, how many are writing Igbo or Yoruba? Now let's go there. The people that are writing Igbo or Yoruba, watch. Look, Igbo and Yoruba, sorry. So Igbo or Yoruba will now be this one they gave me here. Where is Igbo and Yoruba? Igbo. Where is it now? Igbo and Yoruba. Igbo and Yoruba. Yoruba and Igbo, 24. It's going to be 24, but let us get it from the Venn diagram. How many are writing Igbo or Yoruba? Now look at Igbo or Yoruba is going to be okay, it will exist 24. Igbo or Yoruba are people that wrote only Igbo, 24. Okay, plus people that wrote only Yoruba, 33. Okay. Okay, plus people that wrote both Igbo and Yoruba, which is 19. Okay. Then what else? This is difficult. Igbo or Yoruba? Okay. Okay, let us check. In fact, anybody that writes Igbo and Yoruba is what we are taking. 24, 33, 19, 5, 6, and 4. Yes. Everything that entered inside of Yoruba and Igbo is what we are adding. 24, 19, 5, 4, 6, 3, 33. Exactly. So I have what? 24 plus 33 plus 19 plus 5 plus 10. So I have 91. Yes, 91. Very, very correct. Okay. So we go to the next one, IV. Okay, so we move to V. So V said, how many are writing Igbo they say how many are writing both Igbo and Yoruba? Okay, sorry, there is a difference between this one. This one said how many are writing Igbo and Yoruba, but this one has, so this one is saying, I changed it. This one is for V, please. This is V, and this is IV. IV said how many are writing both Igbo and Yoruba. Okay, so the people that are writing both Igbo and Yoruba is already given to us. Both Igbo and Yoruba is 24. Igbo and Yoruba is 24. So let us even get it from the Venn diagram to see if it's correct. How many are writing both Igbo and Yoruba? That is IV. Okay. Both Igbo and Yoruba are the people that are writing them together. So 19 are writing the two of them. 19 plus 5 are equally writing the two of them. So if you add the both of them, you are going to get that same 24. the same answer here. So know the difference between this one and this one. This one said, how many are writing Igbo and Yoruba? So it's either the person is writing only Igbo, or he's writing only Yoruba, or he's writing the two of them. As far as he's writing any of the two, is included. But this one is that you must be writing the two of them. So know the difference between that. So the next question said, that was the last question, VI. So VI said, how many are writing both Igbo and Yoruba but not Hausa? So how many are writing both Igbo and Yoruba but not Hausa? Now, which means the people that are writing, that is the people that are writing only Igbo and Yoruba, which is what, 19. So the answer here is what, 19. So we are done with this particular question. Let me check if my time is still moving. Very good. So we'll move to the next question, question number 7. So this is critical. You need to think. So question number 7 said, in a group of 75 persons, then I said, comma, Tony discovered that 24 persons liked to watch football. They name it A, comma, and basketball, they name it B, comma, 20 person liked to watch 20 person liked to watch tennis. They call it C, and football, they call it A. Okay, then say 9 liked to watch all the three. 9 like to watch all the three, comma, 18 persons liked to watch basketball and tennis. 38 people liked to watch 38 people like to watch football, comma, 36 liked to watch basketball, while 39 liked to watch tennis. Okay, so then I say create a Venn diagram, then we'll now start answering questions. All right, so now first of all, let us create the Venn diagram. Very, very simple to create. So I told you, you start from the intersection of the three of them and then you move. Okay, this is A, B, and C. They want to confuse you with A, B, C. Don't go and name your own. They have named that football is A, so basketball is B, and then table tennis is C. But let us start from the intersection of the three of them. Let's find where they say 9 like to watch the three. So I'll start from here, 9. But let's move to two people. So they say that 24 person like football, like A and B. 24 like A and B. So we say only A and B, because I did not see only, so I have to find only A and B. So 24, only A and B will be 24 minus 9, which will give you 24 minus 9. 24 minus 9 to give you 15. So 15. So A and B is 15. So let's move again. 20 like table A, C and A. So you now say only C and A will now be what? 20 minus that same 9. So you have what? 11. So C and A is 11. So let's go to 24 like 20 like then like okay, let me look for where they say B and C. Is there any place they said B and C? 24 like A and B, 20 like A and C, 9 like the 3, 18 like to watch basket. 18, where is it? 18 like table tennis and basketball. So table basketball is B, B and C. So only they want to confuse you. B and C will now be what? 18 minus 9, which will give you 18 minus 9. Don't allow them confuse you. Minus 9. So which is 9. So here is 9. But let's go to only 1, 1. Only 1, 1. Now going to only 1, 1, they say the 38 like football, and football is my A. So you say only my football A will now be what? 38 minus everything that entered inside of that A. So minus 15, minus 11, minus 9. So let's do that. 38 minus 15, 38 minus 15, minus 11, minus 9. 38, oh my calculator. 38 minus 15 minus 23. So I'm having 3 here. So only 3 people like A. So let's go to B. 36 like to watch basketball, and basketball is B. So only B will now be what? 36 minus everything that entered inside of B. So minus 15, minus 9, minus another 9. So I'll say 36 minus 15 minus 18. So I have 3 again. Oh, 3. So here is equal to 3. So here will be 3. So now let's go to the P39 like table tennis. So only C will now be what? 39 minus everything that entered inside of C, minus 11, minus 9, minus 9. So I will say 39 minus 29. So I'm going to have 10. So 10 is here. So I have 10 here. So we don't have the people that don't play, that don't like watching any of the 3. So we can calculate it by saying add everything in this box, equate it to these 75 persons. So I'll have what? 3 plus 3 plus 10. You see the way I'm taking it outside. Now let's go inside. Plus 11 plus 9 plus 15. Then finally plus another 9. Then plus the x that is outside is equal to what? 75. So if you add these people, you are going to have 3 plus 3 plus 10 plus 11 plus 9 plus 15 plus 9 again. I have 60. So therefore 60 plus x is equal to 75. So my x will now be 75 minus 60, which is 15. So 15 people don't like to play, don't like to watch any of them. So once you have gotten your Venn diagram, you are good to go. So let us now start answering the question with the Venn diagram. So you see that Venn diagram is very, very simple. So the first question here said, create the Venn diagram. I've done that. The second question say how many like football or basketball. So let me write it. How many liked football is A or basketball is B. So let's go to people that like A or B. Is either you like only A, which is 3, or you like only B, which is this. As far as you like A or you like B, you are among 3, 3, 15, anything that entered inside this. So we are removing only 9, only this 10. Add every other thing you are seeing. So 3 plus 3, 9 plus 9, then 15, 11 plus 15. So that is that. So add it. I'm going to have 3 plus 3 plus 3 plus 9 plus 9 plus 11 plus 15. So I'm having 50. Okay. So I. So for I say how many liked. They say I say how many like to watch both football and basketball, but not tennis. So how many liked to watch both both football, my football is A, and basketball B, but not table tennis, my table tennis is C. So it means only A and B, that's the meaning, and only A and B is 15. So 15 is only A and B. We have calculated before. So Ivy said, how many didn't like any of the three? We have gotten it 15. So 15 did not like any of the three. You see? So once you get the Venn diagram, every answer is now possible. Every other answer is now possible and very easy for you to get. So we'll go to question number 8. Question number 8. Number 8 said, let x and y be two sets, comma, such that the number of x is equal to 10 and the number of y is equal to 12, and the number of x union y, so let me write it here, the number of x union y is equal to 15. Then I say, then how many elements? Then I say, then how many elements are in the set x intersection y. The same thing we just did. In the first question. You should know that the number of x union y is equal to the number of only x plus the number of only y, then minus the number of x intersection y. So if you now put everybody, they have given me this one as 15 is equal to this one is 10 plus this one is what, 12, then minus this one x intersection y, which is what I'm looking for. This one move here, this one move here. So n x intersection y will now be 10 plus 12 minus 15. So the number of x intersection y will now be 10 plus 12, 10 plus 12 minus 15. So I have 7. So 7 is my answer, and it's very, very correct. We move to question number 9. We're almost through. Question number 9. Question number 9 said, let x and y be sets such that the number of x union y is equal to 20 and the number of y is equal to 10 and the number of x intersection y is equal to 5. Then I say how many elements are in the set x. The same thing we just did now. Just tell them that the number of x union y is equal to the number of x plus the number of y, then minus the number of their intersection. So x intersection y. Okay, then put everybody. This one is 20 is equal to, I am looking for this one, plus this one is number of y is 10, then minus this one is 5. So collect like terms to see that n of x is equal to, everybody move to this side, so 20 minus 10 plus 5. So my number of x is equal to 5. Okay, sorry, 25 minus 10 is 15. Okay, so that is that. We'll move to question number 10. Question number 10 said, in an art class of 60 students, 36 liked 36 like literature, 36 like literature, 40 students like government. Let me write it in short, government. 24 like both subjects. Then I say find Find the number of students who like. Okay, before I start answering this, let me just draw the Venn diagram. To draw the Venn diagram, I have two things: literature and government. Literature and government. So let's start from the people that like the both. Who like the both? 24 like the both subjects. So here is 24. So let's go to literature. 36 like literature. I did not see only, so I must say 36 minus that 24 to get only literature. So which is what? 36 minus 24 to get only literature, 12. So only literature is 12. So 40 like government without seeing only. So I'll say 40 minus 24, which is what? 40 minus 24. So I'm having 16. So 16 people. So the people that does not like it at all should be here, X. So how do we get it? We say 12 plus 24 plus 16 plus that X is equal to 60 students. Okay. So add everything here. 16 plus 12 plus 24. I have 52. So 52 plus X is equal to 60. So X will now be what? 60 minus 52, which is what? 8. So I have that here is 8. So let's start answering the first question. The first question said only government. Government only. So I told that government only is already gotten 16, which is 40 minus 24, which is 16. I say literature only. Literature only. Literature only has already been gotten, which is 36 minus 24, which is 12. Either government or literature. Either government or literature. So you must be included. So this is this, and this. So which is what? 12 plus 24 plus 16. As far as you are doing any of the two, is correct. So 12 plus 24 plus 16. So I have 52. So Ivy said neither government nor literature. That's the people that not do it at all. We have gotten it as 8. Okay. So question number 11. We are moving to the permanent side. We're almost done. We have just 15 questions. Okay. Question number 11. Question number 11 said write the set X, which is equal to 1, 4, 9, 16 ... Okay. In set builder form. In set builder form. Solution. Problem. So now how do we get this? Now watch. This is 1 plus 3. Problem. You have to think this thing though. I'm going to leave this as the last question I'm going to solve, because you have to think out how this set comes around before you can build it. So question number 12 said write that thing is subset, not subject. Write the subsets of X, which is equal to 4, 6, and 7. So solution. The subset, first of all, you need to find the power of that. So the number of X is equal to, there are 3 number. So the power of X is equal to what? 2 raised power that number of X, which is equal to 2 raised power 3, which is 8. There will be 8 in number. So to list them, the first one is empty set, or you write file. The first one is empty set, set of 4, set of 6, set of 7. Then you have 4 and 6, 4 and 7, 6 and 7, then 4, 6, and 7. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. Complete. So go to question number 13. So question number 13 said they say if X is equal to the set 1, 2, 3, 4, 5, and 6, and Y is equal to the set 2, 4, 6, and 8. Then I say find X minus Y. X minus Y means anybody that is here that you cannot find here. So 1 is here, 1 is not here, 1. 2 is here, 2 is here, out. 3 is here, 3 is not here, 3. 5 is here, 5 is not here, 5. So that is that. Then I say y minus x. Y minus x. Y minus x is the one you can see here, but you cannot see here. 2 is here, 2 is here, 4 is here, 4 is here, 6 is here, 6. So only 8. Only 8. So question number 14. Am I rushing? If I'm rushing, tell me at the comment section. Okay, they say let P and Q be sets defined as follows. As follows. Okay, they now say P is equal to the set of x, which is an element of integers, such that x is divisible by 2. This is a big problem. And Q is equal to the set of y, which is equally an element of the integer, such that y is divisible by 3. Then I say let P and Q, because then I say then P intersection Q is equal to empty set. Okay, there's no question asked here. They have already given you the answer that P and Q is equal to empty set. Yes, because uh, any number that is divisible by 2 can never be divisible by 3. So they don't have anything in common. So it's an empty set. So there is no other question they are asking us there. So we'll go to question number 15. So they did not ask anything there. Unless maybe they want you to explain it. You explain that what? That P intersection Q is an empty set because there is no number, there is no integer that is divisible by 2 that can equally be divisible by 3. So write it like that for them. So question number 15, which is the last question, said in a science class of 100 students, in a science class of 100 students, 35 like biology and like me, and 45 likes chemistry, comma, 10 like both. Then I say how many like either of them, and how many neither. Okay, so before you answer this thing, you have to draw the Venn diagram. So let us draw the Venn diagram. It's very simple to draw. I've taught you that already. So we have two things here. The first thing I have is biology and my chemistry. So this is my chemistry, this is my biology. So who like the both? 10 like the both. So who like biology? Biology is 35, but I did not see only. So I'll say 35 minus 10, which is what? 25. So who like chemistry? 45. I did not see only. 45 minus 10, which is what? 35. Who did not like at all? I did not see it, so it will be x. So add everything and equate to universal set. I'll have 25 plus 10 plus 35 plus x is equal to 100. So add this. 35 plus 25 plus 10 will give you 70. So 70 plus x is equal to 100. So x will now be what? 100 minus 70. So my x is equal to what? 30. So this is equal to 30. So you now write for them that number of they say how many like either of them. So the number of people that like either of them, can I write it here? Number of students that like either is what? 25 plus 10 plus 35. 25 plus 10 plus 35, which is equal to what? 70. So number of students that like neither of them is what? We have gotten it as what? 30 students. So that is that for that. So now the last question, which is this question number 11 that I skipped. The problem here is that we need to think on how these sets are formed. To think on how these sets are formed is what? 1 plus 3. Okay, 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 7 is 16. Okay. Oh, so I'm seeing something here. I'm seeing 1 plus Okay, 1 comma 1 plus 3 comma 1 plus 5 comma 1 plus 7 1 plus 7 comma sorry, oh god, sorry, the first term 1 comma 1 plus 4 comma 1 plus 4 plus 7 comma sorry 1 plus 3. Are you getting it now? So 1 plus 3, 1 plus 3, huh? What am I saying? Let's go again. 1 comma 1 plus 3 to get 4. Now 1 plus that 3, which is 4, plus 5, you get to get 9. Then 1 plus 3 plus that 5, then plus 7 to get 14, then plus dot dot dot. So now this set is gotten by x is equal to an element of odd numbers n plus, okay, let me say an element of x, which is an x, which is an element of a natural number, such that oh god, how do I put this? Oh, how do I build this thing now? I have seen it. Oh, what you do is just that the previous term, you add it to, you add a natural number to the next term. That's how to get it. You add an odd number to the next term. So the previous one added an odd number. Add odd number to this one, you get this one. Add the next odd number, you get this. You like that. So just be adding an odd number. So I can say that x is an element of, so that x plus a will give you the. I don't know how to build it. Please. Bye bye. Thank you. If you know it, tell me in the comment section. Wahala.